Hi guys, it's Shekhar behind the mic. Welcome to this series of visiting planets, spending a day on Neptune. Neptune is the farthest planet from us in our solar system, the blue gas giant. Imagine you are on a rocket heading straight to Neptune. Actually, we wouldn't be heading straight to Neptune because it would have moved from the beginning of the trip. Remember, planets orbit the sun, so we didn't aim the rocket straight to Neptune. Instead, we'll calculate where it would be when we arrive to Neptune's orbit. This is what happens if we aim at Neptune and launch. The planet's all the way over here while we are over here. We will all be screwed. And also let me explain that getting to Neptune would be nearly impossible. Not impossible, just insanely difficult. From Earth to Neptune it would take you about 10 to 14 years, and that's just crazy. Take your age and add the average value of 12 years to your age, and that's how you will be old when you reach Neptune. Well, so much older than you are now, and you have to live in the rocket away to Neptune, flying through the outer space of nothingness. Food and water will be the main issue of the mission. But anyways, we're still heading towards it. The planet was named after the Roman god of sea, farthest planet from the sun, with a mean orbital radius of 4.5 billion kilometers. That is 30 times the Earth's sun distance. In fact, it's so far from the Earth that it was discovered in 1846, more than 200 years after the invention of telescope. Strange enough, Neptune is the only planet in the solar system whose existence was mathematically proved, and this credit goes to two 19th century astronomers, Frenchman Le Verrier and Englishman John Adams. So it was a time when Uranus was discovered, and the problem with Uranus was sometimes it would move ahead of its predicted location, and other times it would fall back. These observations were made over 150 years, with the earliest observation dating back to 18th century. Some people argue that perhaps the measurements carried out in 1700s were not accurate, while others said that perhaps Newton laws do not hold as good for something just far enough from the sun. But Verrier was not among those. He was a firm believer in the sanctity of gravitational laws. He believed that these deviations are due to attraction of yet undiscovered planet orbiting at an even greater distance. Well, Verrier estimated these parameters and calculated an orbit for the new planet so that the deviations of the Uranus orbit could be explained. He published the findings in the series of three papers describing the possibility of a new planet. Here we should not forget the contribution of Adams. However, his plea was failed on deaf ears. On the other hand, just 20 days after the presentation of his final paper, Verrier sent a letter to Berlin Observatory asking them to observe a specific region in the night sky. On the night of September 23rd, 1846, the quest to find a new planet was begun, and they literally found one with 1 degree of the predicted locations. Here in the image, you can see the actual Neptune orbit and the predicted orbit by Ley, Verrier, and Adams, with 1 degree of the predicted location, which was not listed in the star maps. And this led to the discovery of a new planet. In the history of astronomy, it was the first time a planet was discovered with the tip of a pen. Anyways, let's assume that we get to Neptune safe and sound. As we are arriving, we'll see the brilliant blue color of the planet, with gases moving all around its surface. As we enter the atmosphere, we'll see blue tints surrounding the rock. Neptune is famous for something, it's for being strikingly blue. Unlike Uranus, which gets its color from the little bit of methane in its atmosphere, which reflects the blue wavelength of light coming from the sun. Except that's not the whole story. Neptune is actually too blue to be colored by methane alone. Uranus even has more methane in its atmosphere than Neptune, about 2.3 compared to 1.5%, but it's much lighter color. So this suggests that there's another component in Neptune atmosphere which we are unaware of. But since the planet is so far away from us, it's hard to take the measurements with telescopes alone. We'll definitely able to figure it out. No problem. By now, you will be experiencing brutal external force. Our rocket will start to display danger messages, and even alarms will go off, warning us there's too much force acting on the rocket. Well, that's because of the winds. Neptune is well known for having the fastest winds in the solar system, up to 2,200 kilometers per hour. Guys, you can't fully understand how fast these winds are, but that's okay. We never really had that wind speed on Earth. By now, the wind and the gases would have fully relocated our rocket. The speed and the forces are too much for us to handle, so rocket will fly across the atmosphere uncontrollably, probably forever. Assuming that we have the technology to withstand the forces, let's assume we go deeper into the atmosphere. Again, we're still surrounded by blue color, but this time it's darker. If we look out of the window, we'll see the gases moving and flowing incredibly fast, like an insane stream. Now, as we approach the surface, you're going to start to feel really tense. Your back and spine will start to hurt. Your legs, your torso, everything probably to a point where you can't handle it. You will start to scream with pain. And why that's so? Because the gravity of Neptune has started to kick you. Gravity of Neptune is about 119% of Earth. If you weigh 100 pounds on Earth, you'll weigh 119 pounds on Neptune. That's extra pounds on you. Now that will start to give you an intense pain. As we go deeper, actually we can't go deeper and deeper into the planet because it's a gas planet. So there's no solid surface. Therefore we can't land. Instead of landing, we can hover the rocket above the surface. But that's nearly impossible task to do because the winds because of the winds. But let's just imagine that for the sake of this presentation, we did it. Neptune is composed of about 80% of hydrogen, 18% of helium, 1.5% of methane, and some small amount of ices such as ammonia ices, water ices, and methane ices. Methane is what that gives the planet a nice blue color. But remember, methane is extremely dangerous for us to breathe. Same with hydrogen and helium. You will suffocate if you breathe it in. There will be gases flying everywhere at faster speed, including the ices. Being exposed to this type of weather, even if you are in a spaceship, will definitely kill you, and the winds and ices will tear your fur. That's not feasible. Experiencing with the temperatures down to negative 214 degrees. Since Neptune is the farthest planet from the Sun, you would think it would be the coldest, but that's not the case. The honor actually goes to Uranus, where the temperature around its cloud is about minus 220 degrees Celsius. Admittedly, that's not a huge difference, but considering Neptune is around 1.5 times as far from the Sun as Uranus and more than 1.5 billion kilometers farther, it's strange that the planet wouldn't be colder. When you combine that with infrared measurements taken by the Voyager 2, it suggests the planet is radiating heat. It looks like something is warming Neptune's interior. We just don't know what it is. Over the years, papers have suggested being heated by moon tritium, which could cool on the planet and generate heat from the friction. 2017 paper in Nature Astronomy suggested the heat would be coming from sinking diamonds of all things. That idea says the pressure is so high inside the Neptune that carbon atoms get compressed into diamonds. Then, as those heavy metals sink towards it, the planet's core generate friction that causes things to heat up. And while that we would be awesome, it's hard to know that for sure unless we take more measurements up close. But anyways, minus 214 degrees Celsius, your body will instantly freeze. Heat will rush out of your body at an extremely fast rate, and your body cells and molecules will start to slow down until they are almost freeze. In whatever position you are, the winds and the external forces acting on your body will make you shatter into small pieces and sending you flying across the atmosphere of the planet, never to be able to see again. Neptune has extremely strong magnetic field, almost 30 times more powerful than Earth. It also misaligned compared to the axis of planet rotates. Its magnetic field is tilted about 47 degrees and we are not sure why. According to 2004 study in the journal Nature, which is based on computer models, the tilt could happen if Neptune interior is different from most of the other planets. Specifically, if it has a liquid core instead of a solid core like Earth. Solid core don't allow magnetic field lines to fluctuate as much. So if Neptune does not have one, its field lines could get tangled up and ultimately misaligned. But there are also plenty of evidence that Neptune actually does have a solid core. Another most recent model suggests that magnetic field issues might really be caused by a special type of conductive hydrogen close to the planet's surface. Finally, you might know the Jupiter's red spot, and the credit as the most famous storm in the solar system. But Neptune has a pretty cool one. When Voyager 2 showed up in 1989, it took photos of the so-called Great Dark Spot. It was huge, swirling storm roughly the size of Earth, and it had winds up to 220 kilometers per hour. Except when we observed Neptune again in the 1990s, this time using the Hubble Space Telescope, it had disappeared. We weren't able to confirm any new storms of that magnitude till 2006. But in 2006, when Hubble spotted anomaly in southern hemisphere, but there's still not much we can do from Earth to study. Since Neptune is so far, it's difficult to observe these storms. Let's alone get data from them. So far, the most we can say is that the storms on Neptune aren't very consistent. They showed up in different parts of planet, drift in different ways, and come in all kinds of shapes and sizes. So far, everything about this planet is brutally bad, and anything good about it, well, in short words, no. Now, going back to our senses, if you could smell Neptune's atmosphere, you wouldn't be able to smell anything much maybe except a little scent for protein eggs because of methane. And just wait, are we forgetting something? Right. Well, that's the planet satellite, the moons of Neptune. Well, Neptune has got 14 moons revolving around. The names are Naiad, Thales, Despina, Larissa, Hippocamp, the smallest one, Proteus, and Triton, Nereid, Helmet, Sao, Laomedeia, Asmatic, and Niso. But the most significant one is the Triton, the largest moon of Neptune. Triton is the largest natural satellite of the Neptune and the first Neptunian moon to be discovered. It was discovered in October 1846 by William Lassell. It's the only natural moon with a retrograde orbit, that is, an orbit in the direction opposite to planet's rotation. Triton is the seventh largest moon of solar system. Because of its retrograde orbit and composition similar to Pluto, it is termed as dwarf planet captured from Kuiper. So now we came to the end of our trip, and I see that going to Neptune is a failure. The journey is too long, the planet's not even solid, the winds are too strong, and it's so cold. After spending 16 brutal hours, which is how long a day in Neptune, we finally out of the net. Thanks, Neptune. And that's conclude the second last video of the series.